Hello. Yes, good. Awesome. Thank you for those of you who stayed to watch me again. And the people who stayed probably know that I like to start all of my talks with a question. So I'm going to start this talk with a question. So who here wants to be rich? Yeah? You're in the right place, because I am going to show you a guaranteed 100% foolproof method to becoming insanely rich. Okay? And we're going to use this guy. Okay, whether you love him or whether you hate him, there's two things that are true about Donald Trump. He loves tweeting. He loves Twitter. Yeah? And also he's very influential. Who wouldn't want 100,000 likes on their tweet? But some people argue that he's so influential that he moves markets. So this is him talking about saying something bad about Toyota Motors. And this is the exact moment he said something bad about Toyota Motor, boom, the price of Toyota Motor went down. Okay? Now, I wasn't the first person to discover this. In fact, neither were these guys. But I found out about it because of this podcast called the Planet Money Podcast. Does anybody listen to this podcast at all? There you go. So I have to say this, I am not affiliated with the Planet Money Podcast. And the Planet Money Podcast does not endorse me or my company. Thank you. Legal terms over. So the Planet Money Podcast, I spoke to them, that they're fine with me talking about boats. I spoke to them and they cottoned on to this idea earlier on in the year, and they hired a high-frequency trading firm to see if they could make money from Trump's tweets. And they tried building one, and they actually released it on Twitter. It's called BOTUS, Bot of the United States. The president of the United States is called POTUS, president of the United States is called BOTUS. And if you want to find out what it's doing, you can follow it on Twitter, you can see what it's done. But unfortunately, literally 2 weeks ago, they shut it down. Because, there was a podcast that was basically, the people who were part of the podcast were putting money into it. They wanted their money back. It was only for educational purposes only. And the thing is, Donald Trump was really sad about this. You can tell because he said, epic fail, sad. So you know he was really sad about it. But don't worry, because I am going to show you how to create your own BOTUS. Again, this slide. Who am I? My name's Asim Hussain. You can find me on Twitter @Jorik. Follow me on Twitter. I blog about Angular and JavaScript on my site codecraft.tv, and I'm a cloud developer advocate at Microsoft. So I work with the Azure team, and I'm a conduit for the Azure team and developers like yourself. So if you've got anything you want to say about Azure, good or bad, come speak to me afterwards. But honestly, seriously, if you're using Azure, when I go back to Microsoft, all the PMs are just like, what did they say to you? They really want your feedback. So if you've got anything to say, honestly, positive or negative, come speak to me. So I made BOTUS. And I wanted to share to you today how I made BOTUS and all the nitty-gritties of it. And this is actually what I created in the end of the day. The Planet Money Podcast made a version of the trading bot which traded stocks. I made one which traded FX, currencies, and that's because when President Trump started his presidency, he was saying lots of things about companies, which was affecting the company's stock price. Now, later on in his presidency, maybe somebody's had a word with him, and he's kind of stopped saying things about companies. So one of the reasons they shut down the trading bot was just it wasn't doing much because Trump wasn't talking positively, negatively about companies anymore. But he does talk positively, negatively about countries, which makes currency trading very interesting. So this is the version of the application. This is the tweets page. So you can see here, this is the at the time I took this video, the latest tweet. And this is a positive tweet that relates to Vietnam and the Philippines. I'll just show you the application. Scroll down, you can see some tweets. If he's smiling, it's a positive tweet. There's the angry face, which is a negative tweet. So Kim Jong insult me by calling me old. I don't know. And sometimes if it's just if the algorithm can't detect if it's a happy or sad tweet, it will just be a normal face. And then that will trigger a bunch of trades. So in this one, it made a buy of Chinese renminbi. I don't know if I'm saying that right, so I say it in a stupid voice. And then this is the portfolio. This is actually what it's created. So it's borrowed like $1,600, and this is all the current value of all the currencies that it's bought based off of positive and negative sentiments. And I forgot to actually put on this page, I can't believe I forgot it, is the actual amount of money that's been made. At the point I took this video, it was $61. Yeah. Positive. It's the best investment I've ever made. Apart from I've got 0.2 bitcoins, which I've lost, which I wasn't bothered about until, a few months ago. So if anybody can help me figure out how to get that 0.2 bitcoins back, I'll be very, very appreciative. But anyway, so that's the application. What are the rules of this trading engine? A positive tweet. If I detect a positive tweet, I will buy $100 of the currency. If I detect a negative tweet and I own some of that currency, I will sell all that currency. If it's US dollar, then I inversely buy and sell gold. So that's kind of an activity. So basically, if you say something negative about America, that's negative US dollar, the way to counteract that is to buy gold, to kind of counteract that, right? Position, so this isn't a high-frequency trading engine. It's not. It's a very, very low-frequency trading engine. Positions are held overnight, so just however long I'll hold them for however long it takes to make money. And no money was harmed in the production of this trading bot. It's all simulated. Thank you very much. Thank you. So what are the steps to creating a bot like this? First, you need to get the tweets. Then you need to analyze the text of those tweets. You need to store that data somewhere. You need to make trades. And I want to do this whole thing so it's scalable, elastically up and down, because I'm using Trump as an example. And there are people doing this. You probably want to use kind of a collection of people or a group or something along those lines and get that fire hose and figure out sentiments from there. So you need something that can scale quite drastically with load, because Twitter can publish a ton of data in a short space of time. So first challenge, getting the tweets. Sorry, 1 second. Oh, the tension. It's going to be very disappointing. Because I used a feature in Azure called Logic App. So has anybody used Zapier or IFTT or things like that? Okay, yeah. So in Azure, it's got something called Logic Apps. It's a great way of kind of prototyping applications and just figuring out stuff quickly. And there's a bunch of different connectors. And there was a connector for Twitter. So whenever Donald Trump tweets, I can start a visual workflow. I mean, you could do it this way. You can also just write your own APIs as well. But there's so much code out there for how to get information on Twitter. You can figure it out. Because we're now going to move on to the more interesting act of how to analyze the text. So the question is this. If 0 is a negative tweet and 1 is a positive tweet, what do you think this is? Where is it closer to? 0.3. Oh, you're so positive people, because it's actually 0.014. Okay. One thing with Trump that they found in the Planet Money when they did this, they found that was really good about Trump's tweets is that he's really obvious with what he says. There's no double negatives like this is not good. This is like everything is very, very, very bad or very, very, very good. So the sentiment analysis on Trump is quite good, and it kind of clearly goes one end or the other. So it's pretty cool, actually. But how do you do this? How do you actually do sentiment analysis? So what you do is you get a training data. You get a training set. So you get a bunch of data, and then you've got somebody out there has figured out manually whether it's positive, negative, or I don't know. Okay, you start off with a whole bunch of training data like that. And it's subjective as well, remember. So one person might think, no way, I love that is actually negative. Or let's meet at 10 p.m. Somebody might say that's positive. I don't know. Depends, it's subjective, right? So then what you do is you take that training data and you feed it into something called a classifier. And it kind of churns away in that training data. It kind of learns. And the output of all of that is a model. And then what you want to do, now you've got your trained model, what you want to do is you want to pass strings to it. Oh, this shouldn't be... So you pass strings to it, and it will spit out a number, depending on whether it's positive or negative. Okay, so that's kind of the general idea of how you do sentiment analysis. But essentially, each piece of that text, of that tweet, is called a feature. Okay, a feature in AI. Now, the most basic feature can just be a set of words. So you take that tweet, you split on white space, boom, that's it. And it's called tokenization. At the end of it, you can just get like what's called a bag of words, just a big bag of words. Okay, now you can actually do training with sentiment analysis just on that big bag of words, with not much more else. And it's not too bad, actually. So sometimes it's okay, but you can actually do better with more complex activities. So we can do things like stemming, n-grams, part of speech tagging, and word embeddings. So I'm just going to quickly take you through all of these terms so you kind of get an idea of what's involved. So stemming, love, loves, loved. So like, they kind of mean the same thing. Maybe not loved, that was probably a bad example, that's probably negative. But love and loves and love, they kind of are the same words, but they have different endings, kind of have the same meaning, but different endings. So there's a bunch of different tools and algorithms and libraries out there you can use to do something called stemming, which is to take a word and get the stem of it, the root meaning. Now, it's also language specific. So there's English ones, there's Spanish ones, there's French ones. It depends per language. So stemming actually works differently depending on the language that you're using. But that's one thing that you would do is you take all those different words and just get the stem of them. Another thing you want to kind of take into account is n-grams, right? Asim is shit. There's a different meaning to Asim is the shit. Okay? So what do you do? Like, if you just looked at the individual words, the algorithm wouldn't be able to detect that shit is good or bad. It's just another word. So what you do is you might turn it into something called bigrams, for instance, right? So you take like the individual words, Asim is shit, but then you take individual pairs of words. Asim is shit. Asim is the shit. Asim is the shit. And then, if you think about it, the computer then can detect that is shit is probably negative, and the shit is probably positive. You use a thing called n-grams, and you can actually increase the number of n-grams that you want to do. Don't take a picture of sorry, no, take a picture. I'm joking. I don't mind. Please tweet that. I will retweet it. I've lost what I was talking about. So like is shit and the shit. Oh yeah, and you can expand out the n-grams, so you can have 2 or 3 or 4. You'd actually probably play around with it and figure out which number of n-grams that you'd want to have, right? To see which of them does a better job. But 2 is pretty good, right? See, just with 2, you can add a lot more meaning to it. And there's also something you can do called part of speech tagging. So Asim is the shit. Like in sentence, you kind of know what that means, but when it kind of gets converted into a big set of data, it can lose the order, right? Because like depending on the context, the word table, for instance, can mean different things. It could mean a place where you sit, but you can also table a discussion. You can use it like a verb. So another thing you probably want to do is to associate with this the context from which it was first discovered. So you do something part of speech tag in which say against each word you give it a special code which describes where it was in the original sentence. So I'm actually really bad at grammar, to be honest with you. I'm the worst. But DT is a determinator. Dot is called a sentence terminator. NNP is a noun proper singular. NN is a noun common singular or mass. And VBZ is a verb present tense third person singular. So, of course, it's clear. So we feed that into the algorithm as well, into our training. We add this to our training set as well. Another thing you can do, and this is kind of, the other stuff I showed you is kind of very, very commonly used in a lot of natural language processing, but you can also people also start to use things called word embeddings, which is basically trying to figure out if words are related to each other. So a pet, a dog and a cat are kind of the same thing, so maybe you should treat them as the same thing. Maybe this is similar to a pet, but for sure a cat is not similar to a vehicle, a car, or a truck. So kind of grouping words together, in fact, it appears on the kind of a vector space, and you'd associate basically a bunch of numbers with it. But essentially, seeing if certain words are kind of the same thing and therefore are valid. When it comes to kind of AI, you can do a bunch of different things. You can actually just do what I've just showed you, get all that data, use the NLTK toolkit or whatever toolkits that you want to do, and train your own model. Okay? And there's plenty of solutions. You can do that if you're using Azure. You can use all of our GPUs and all the servers that we have that specialize in helping people train AIs, right? I don't like doing that. I like doing the other end of that spectrum over here, the pre-trained models. Okay, so bunch of different services now. We've got them as well in Azure called cognitive services, which are basically just we've trained all the models for you. You just can use them. If you can make a HTTP request, you can do AI. That's all you need to do. So we've got one called Text Analytics API. So easy to use. You just give it your text, do HTTP request, and it gives you a bunch of data back. And I think we give 30,000 requests for free. Don't quote me on that. So that's one of the things I use, Text Analytics API. Really easy. And it also gives us back key phrases. So it extracts from the text certain words. So Mexico is a useful one for doing currency trading. It also gave me Toyota Motor, but then I'd have to go figure out like what ticker symbol is Toyota Motor and what stock market to trade it on. So again, you can do it on stocks if you want to do it. And again, really cool thing about this is, about Logic Apps, is that all that stuff's available as connectors. So the next thing all I had to do was basically drag and drop a few things, and I've got tweets coming in, I'm analyzing the sentiment, and I'm analyzing the key phrases. Pretty easy, right? But then we also want to kind of talk about data, because I can't just make trades just off tweets. I need to know the stock prices, I need to store the trades somewhere, I need to store the price somewhere, I need the history of stock prices. I need a bunch of these different things, currency rates. So yeah, I've got the currency rates from Open Exchange Rates, and fine, you know, it's got an API, you can use it, it's free, you've just got node modules, whatever, APIs and a bunch of different things. Fine. That's the easy part. The really interesting challenge, I think, is what do you do about data? Where do you store that data? You can use a bunch of different database systems. I really like using Redis. Does anybody here use Redis? A few hands. Have anybody here used Redis not just as a cache, but as a database? One. There we go. This guy knows something that you all don't know. Redis is an completely different kind of tool. Okay, you've got SQL databases that we've all probably heard of and known and used. You've got NoSQL document-style databases like MongoDB. And they're good tools to have in your toolbox. I really like Redis because it fits an area which both of those don't fit. And you'll never know how useful it is until you start playing around with it. I'm going to show you how some of the features of it. And the data we're storing is called time series data for the most part. Tweets happen over a series of time, prices happen over a series of time, trades happen over a series of time. But the really important thing about Redis is that it's something called an in-memory database. So why do I like in-memory databases? It's because of this. This is like a really good explanation of the different speeds of things, just to put it into a more human understandable context. So a CPU cycle, I was going to do this originally by skipping and getting an audience member to skip this, but we'll see. I won't be able to do that today. I forgot my skipping rope. But anyway, so one CPU cycle is 0.3 nanoseconds. A CPU cycle is actually the amount of time it takes for the electricity to kind of like do a full circuit on and off on a CPU. It's the time it takes for a CPU to execute one instruction, one machine code instruction. Okay, so it's the kind of lowest level thing you can do. So one CPU cycle is 0.3 nanoseconds, which if in human terms, let's assume that's 1 second. Level 1 cache is like if you've seen when you bought computers, you'll see CPU has level 1 cache, level 2 cache, level 3 cache. Level 1 cache is a type of memory. For the CPU to get data from that memory would take 0.9 nanoseconds, so 3 seconds. Level 2 takes a bit longer. Level 3 takes a bit longer. Main memory will take 6 minutes. So if the CPU needed to do something and asked for data from memory, it would take 120 nanoseconds to access it. But look at the jump between that and disk. Right? A huge jump. Huge jump. That's why we have memory. Okay? Memory is much, much faster to access than disk by a long way. Okay? So a lot of these other databases which we're used to using, like SQL databases and Mongo and all this stuff, they're still storing stuff on disks. They're still really slow. Redis is only storing stuff in memory, so it's insanely fast. Insanely fast. And that's why I like using it. Now, one of the disadvantages of using Redis as an in-memory database is if you want to store 10 megabytes, you need 10 megabytes of memory. If you want to store 100 megabytes, you need 100 megabytes of memory. It stores it to disk, but you need that stuff in memory to be able to use it. So you can't really store a lot of data in it. But it can do a bunch of different things. So you can store strings, maps, lists, sets, sorted sets, a bunch of different things, different data types. There's other data types as well. It has a command line interface. So if you want to set some data, so you can set the value key. It's a key value store. So you can just do that quite easily with set and get. You can also store hash-based data, so a hash, a field, and a value. Store and retrieve. You can also, but like what we want to store for prices is something like this. We want to store for GBP/USD for a particular date, that was the rate. And then at the same time, I also want to be able to query from it to say I want data from both those days. So we can use something called a sorted set in Redis, which is really useful. I think it's one of the most clever features or useful features of Redis. I use it all the time. And basically, you can set on a key some value, give it a score, and it will keep it sorted versus the score constantly in the database. So we really want to do something like this. So the key name being GBP/USD. The score will just take the date time from Unix time, and then the value. But actually, because it's a set, it means the values have got to be unique. So the other thing you need to do is basically make the value unique. I just basically append the time to it with a colon. And then you end up storing your data something like this. And then you can get your data from a range of dates and times with zRange by score. You can pass in GBP/USD, start time, end time with scores, and it will return you the rates for those between those dates. So pretty useful. I just wanted to show you Redis so you'd understand that it is a pretty unique type of database system, and I think it's really important to just go and learn it. Just read the docs for like an hour. Maybe you won't use it today, but you'll probably be faced with a problem some point in the future, and you'll think, Redis. Finally, making trades. How do we do this? Well, I don't actually make any trades. As I said, it's all simulated. But we need to figure out from that tweet, from that price, should I buy or sell this stock? And it's fairly, I basically get the tweet, I load the portfolio, so I make sure I've got some data there. I then want to figure out exactly what is he talking about, because is he talking about, get the currency that he's talking about from a country. Then if it has some country data, I'll then pass it through the engine, which then basically decides should I buy or sell the stock. All the code is going to be available online, so you can have a look at it. But the real question I want to answer is how to solve this problem in a scalable way, right? Because I need to host this code somewhere, and this code needs to handle just a whole ton of tweets or just a little bit of tweets. Okay, and you can either host it. There's basically a bunch of different options. You can either do on-premise, which is how we used to do it, or how a lot of people still do it, actually. So we've got our function here that little function I want to execute. It's probably sitting inside a framework, like a web framework. Maybe it's Node Express or something like that. That's sitting on an operating system, and that's sitting on some hardware somewhere. And if you own all of this, it's called on-premise. But then if a hard drive fails, you have to go fix it. So then companies came along like Azure. And we started offering things like virtual machines. Okay, so we just give you the hardware, you install the OS, the framework, your function, and then you go wild. That's called infrastructure as a service. But then people got lazy, they wanted a bit more help, so we started offering things called PaaSes, platform as a service, which basically, you don't even worry about the operating system. You just give us your application code, and we run it for you. But now, the exciting stuff that's happening in the world now is PaaSes, functions as a service. So basically, you just give us that individual function. That's it. You don't bother with your framework, don't bother with anything else, just that individual function. And we'll host it for you, and we'll scale it in and out. In Azure, you can do it in a bunch of different ways. You can use VS Code, the command line, Visual Studio, whatever. Or you could just use the web portal and just literally paste in your code, and it gives you an endpoint. It gives you an endpoint, which you can then pipe into your logic apps. So that's it, and that's basically, FAS is basically called serverless, serverless.new serverless architectures. And it might be a bit confusing because you might say, well, everything uses a server somewhere, so what is serverless? There's a million different definitions going out there in the world as to what serverless is. The definition I love is you pay only for actual usage and not for predicted usage. So if you deploy that function and you never call it, not even once, you pay 0. If you call it 1,000 times, you pay for it 1,000 times. If you deployed it on a server and you never call that function, you're still paying for that server. And you have to predict future usage. With serverless, you only pay for the exact number of usage that you've used. Summary. Oh, that was fast. Summary. Try logic apps if you want. They're a really quick and easy way to prototype applications. AI is a lot more accessible than you think. Search out cognitive services and a bunch of different things. There's a bunch of different APIs that you can use. I often feel like a kid in a candy store connecting these things together. And also check out serverless. It's pretty cool. And if you want to see the code for this, or if you want to see the application running, go to botus.codecraft.com, but not quite yet, because still needs a little bit of tweaking before I publish it. And yeah, that's it. Thank you very much for your time.